Hello everyone, my name is Shri and my teach one is on lasso regression. Lasso stands for least absolute shrinkage and selection operator, statistical formula primarily used for feature selection and regularization of data models. The question is, using lasso logistic regression, identify the relative weights of each symptom, pair of symptom and triplets of symptoms in diagnosis of COVID-19. Use polynomial function to create interaction terms for symptom, lists the non-zero coefficient for each of the C parameters, and report the McFadden pseudo-R-square. First, we are going to start by importing the necessary libraries and then loading a data set that has COVID-19 test results and symptoms reported by individuals. We only keep rows where the test results are either positive or negative. Data pre-processing, it includes conversion of variables into binary values. We created a new column to represent test results as binary values, one for positive, 0 for negative. We also create binary columns for each symptom and other factors like age and vaccination status. And then we are going to map and rename the columns. Combining and binarizing the symptoms, we merge all symptoms columns into a single column for easier analysis. For each symptom, we create a binary column indicating whether a person experienced that symptom or not. We drop unnecessary columns and keep only those that might help in predicting COVID-19 positivity. Convert age to categories and clean column names. Graphical representation of lasso regression using cross-validation. Export all the pre-processed data into a CSV file. We split the data into training and testing sets to evaluate our model's performance. Create a plot for graphical lasso regression. Polynomial interactions. We create interaction terms using a polynomial function. This means looking at combination of symptoms to see how they jointly influence the likelihood of testing positive. Running lasso logistic regression for C0.1. Look for symptoms or combination of symptoms that have non-zero coefficient. This means they are significant in predicting COVID-19 positivity. And then calculate the McFadden pseudo-R-square, a measure of how well our model is performing. Graphical lasso regression representation of hyperparameter C0.1. Repeat the same steps for other two C parameters and store the results. Graphical lasso regression representation for hyperparameters C0.01 and 0.001. Interpretation of results. Non-zero coefficients were found only in hyperparameter C0.1. For example, cough, loss of appetite 0.189 means that having a both cough and loss of appetite increase the likelihood of testing positive. The larger the coefficient, the stronger the relationship. No non-zero coefficients for C0.01 and 0.001 were found. These values are too restrictive to identify any significant relationships, suggesting fewer symptoms are predictive at these levels. Usually, non-zero coefficients suggest that these symptoms contribute significantly to predicting COVID-19 positivity. Lasso regression helps us identify which symptoms are most important for diagnosing COVID-19. By focusing on symptom interactions, we gain a better understanding of how they work together in predicting outcomes. McFadden pseudo-R-square for each of the C parameters. For C0.1, the model explains about 27.1% of the variability in test results. For other values of C, the model performs worse than a simple average model. It helps in overall identifying important symptoms, helps in guiding healthcare decisions, understanding COVID-19 patterns, and improving diagnostic accuracy. Thank you.